So I forgot to hit record in class, which is something that I'm hoping you guys can remind me to do. But I'm just going to go through the slides that we did and remind you guys. So we did the kind of this first example when we were talking about domain. And I posted 3 functions, just 3 different functions. Since they're different ones, that's why we had to give them different letters. And then you talked about what the x values would be. So in the first example, x could be anything you wanted it to be. Wait, what's happening? Okay, sorry. So, in this case, the answer was all real numbers, or you could say it goes from negative infinity to positive infinity if it's like the graph, because x could be anything you want. Every single number you can think of, you can plug in for these x's, and you're going to get a real number back out. Okay, so there's no radicals, no fractions. When you have a radical, the problem is you cannot have a negative underneath. So in order to tell what x can be, what are all your x's available, you have to set that equation, and I think I have this little shrinking thing down here. You have to set that equation, set what's inside. So notice I took the x minus 5 that's underneath that radical. I set it greater than or equal to 0, and then you solve, which means get x by itself by doing the opposite. So x has to be greater than or equal to 5, and that's the domain for this radical. Then we have, whoops, wait. Okay, then we had the last one. We had the fraction. That's the one that might be most difficult. So the problem with a rational expression, a fraction, is that you cannot have a 0 in the denominator. So we had to find out what might make 0 in the denominator. So we took, let me just shift everybody out of the way. So we took what was in the denominator, the x squared plus 4x plus 3, we set it equal to 0, and we started solving it. When you have a quadratic, you check to see if you can factor it, meaning, is this the product of 2 parentheses? In this case, it is. So you take the last number, you figure out what are 2 things I can multiply to give you 3. 1 times 3, that's the only option. So that tells you what numbers go in the parentheses. I want them both positive because I want to add them and get a positive 4. And then x times x is x squared. Once you have it factored, and you want that equal to 0, that means either the first parenthesis, let me move that out of the way, either the first parenthesis, x plus 1 is equal to 0, or the second parenthesis, x plus 3 equals 0. One of those would have to be 0 in order to multiply them and get 0 for an answer. So we solve each one, and we find out the 2 numbers x can't be, so that's why we make sure to write it with a not equal to symbol. So x could be anything you want, all real numbers, except, that's why we have the not equal to, -1 and -3. That was our domain for that last problem. Let's see what we had down here. So then I just gave you some notes and said, so domain, if you have a square root symbol, you're going to be limited because you can't have negative inside. And if you have a fraction, you're going to be limited because you can't have a 0 in the denominator. I just realized I'm recording that video with TV in the background. That's annoying. Sorry. Okay, now I have 2 more functions. So the next thing we did in this slide is I gave you another f function. That one was a square root. And then we practiced with a g function that was a fraction. So over here to the right, you see the solution for that one. We took what was underneath the radical. We set it greater than or equal to 0. And we solved it. So that means always doing the opposite. Add 7 to both sides. Then divide by 2. So x would have to be greater than or equal to 7/2. Over here, our only concern is that we don't want a 0 in the denominator. You can't cancel anything out. This plus sign and this minus sign are like little handcuffs. So they bind these terms together, so you can't cancel anything. But we do have to check and see, is there anything that might make that denominator 0? So we take that denominator, 2x minus 5, you set it equal to 0, and then you solve it, and we get to x is equal to 5/2. We have just discovered what would get plugged in for x that would give us a 0 on the bottom, and we can't have that. So this is the way you write your answer. X is all real numbers, except that means it cannot equal 5/2. These are the class problems that we did. We had 4 examples. So these are the problems we worked in class. I'll just go over the answers with you. So in this one, we had to take that denominator, set it equal to 0, and solve it. When we factored that, when you factor this, when it factors as x minus 5, x plus 2, if you multiplied that, if you FOILed that out, you would get x squared minus 3x minus 10. So once it's factored, that's how you go from the factored form to your answers right here. You set each of those parentheses equal to 0, and you solve them, and we found the two things x can't be. Oh, look, so I found a mistake from class. We needed to have a not equal to symbol right there. Okay, big shocker, mistake in class, huh? So, all real numbers except -2 and 5. The second one, when you have a radical, you set that greater than or equal to 0, and you solve it. Subtract 5 from both sides. Divide by 3, we ended up with this. X has to be greater than or equal to -5/3. Same thing on the bottom one, but the bottom one was a little bit different because this one we could factor. And so I'm going to scoot this up and show what we showed in class. So the denominator, I have x's in both of those. It's not a trinomial. There aren't 3 terms, so I can't do the parentheses thing. But I notice both those things have an x. So I took that denominator, and notice I factored it down here. I took an x out because they both have an x. That's factoring. And then what I noticed is that now I have an x in the top and bottom that's not being added or subtracted. And those will cancel. And what you're left with, anytime you divide something by itself, you get 1. So there is the number 1 left on top. 4x minus 5. So that function reduces to this. And then when you set the denominator greater than or equal to 0, that's how we end up with this right here. X cannot equal 5/4. So you set that, I said greater than or equal to 0, and I apologize. Set that equal to 0. You move the 5 over, and you divide by 4, and you get this right here. X cannot equal 5/4. The last one was a combo. And so the reason it was a combo is we had both things present. Not only did we have an x plus 6 in the denominator, so we know x can't be -6, but we also have a square root symbol in the denominator, and that means we can't have a negative under there. So really what you do is you do like you do anytime you have a radical. Take what's inside, set it greater than or equal to 0, and solve. Well, initially what we got when we did that is we got this x is greater than or equal to -6. But because it's in the denominator, we can't have an equal sign. It can't equal -6. We just talked about that. Sorry, you guys. I was trying to do my laser pointer, but I realized I had moved my icons around. So what we had to do is take off that negative part, okay, because we can't have equal to -6. So the answer to that one was just x is greater than -6. So that was our combo. Next, what we did in class is I gave you 2 functions. We have an f function and a g function. And this time you're doing the same skill you did for homework. You're doing f divided by g, g divided by f, g of f. But now we wanted to look at the domain, which is what you just finished doing. And we wanted what the function was. So we're combining the last 2 skills together. Again, the nice thing about these videos is that if I'm going really fast and you're having trouble writing down, the beauty is you can pause anytime. Rewind it, back it up, listen, rewind, pause, whatever you need to do, just so you know. But I'm always going to talk fast in a video because you have that ability. And we don't ever want a video to go too long for those that don't need that. Okay, so f divided by g. So we take the f function, put it on top. That was 2x minus 7. The g function, we put it on bottom. And there's nothing we can factor, and there's nothing we can cancel because we do have a plus and a minus binding these terms together. So we just go straight to domain. Set that denominator equal to 0, solve it, and you get that x cannot be -1/3. This time we want the g function on top. That's 3x plus 1. The f function on bottom, that's 2x minus 7. There's nothing we can factor or cancel. So we set the denominator equal to 0 and solve, and that's how we got that x cannot be 7/2. G of f of x, remember that means you start with the f function and you pick it up and you plug it inside the g function. The g function was 3x plus 1. But instead of the letter x, we have this entire f function now. You have to distribute that 3. So that 3 gets distributed to both of those things. You ended up with 6x, oh, it's sitting there, sorry, 6x minus 21, and then your plus 1. The negative 21 plus 1 is how we got 6x minus 20. And because, now remember, we want domain. There's no fraction here, and there's no square root. So the domain is all real numbers. Then I gave some in-class problems. Looks like we had this f function that was a radical and a g function that was not. We did f times g, which was funky, but the only problem with f times g that affects your domain is that you can't have a negative under the radical. So we did the same thing we always do. We took what was inside, as you can see down here. We set it greater than or equal to 0, and we solved it. So x has to be greater than or equal to 2. G divided by f. The g function is sitting on top. The f function is sitting on bottom. So let me scoot this a little bit up. So what we did is we did like we always do. We took what's inside the radical, we set it greater than or equal to 0, and we solved. So we said x is greater than or equal to 2, but then we remembered because it's in the denominator, it can't be equal to. So we physically erase the equal to bar, and it's just x is greater than 2. My dogs are running around like crazy. Oh no, she's going to throw up. Okay, that's pleasant. Sorry. Okay, well, I was right. That was fun. Okay, so the last one I think I remember. So we're on f of g of x. So we picked up the g function, which was 4x plus 1. And we plugged it into the f function, which means we had to do the square root of the 4x plus 1 that we just plugged in, minus 2. You get 4x minus 1 under the radical. Now we need domain. Domain says you take what's under the radical, set it greater than or equal to 0, and solve. So we add 1 to both sides. You get 4x greater than or equal to 1, and then you divide by the 4. So that's how we got the answer of x has to be greater than or equal to 1/4.